Hello, it's Carlos Ruiz, Solution Engineer at BMC. Thank you very much for watching my video. Today, I'd like to discuss how you can connect your mainframe with Control M for distributed using the automation API capabilities. This is very useful when you want to connect your legacy scheduler, which is taking care of some workloads in your mainframe, with Control M platform. So for doing this, we have prepared this agenda for today's session. First step, we will discuss a little bit about different scenarios. Then we'll go into the architecture. After that, we will describe the benefits of using this solution. Then we will talk a little bit about the resources and prerequisites. And finally, we will do a demo. Let's discuss about the scenarios. Of course, your first option should be having Control M for mainframe plus Control M for distributed. This is the best scenario. Why? Because all your workloads will be managed from a single pane of glass. You will get an optimum performance of the platform. You will get also native integration between servers through global conditions. So it's very easy to connect a job that is running on the mainframe to a job that will run on the distributed side. And you will have full visibility using the same tool. Everything will be fully integrated. And finally, this is a very robust architecture. So again, this is the best scenario. But in case you don't want to have Control M for mainframe, we have a different approach. We have a different possibility. So let's imagine this scenario. Currently, we have a legacy scheduler running on mainframe plus a Control M for distributed. Once a job finishes on the mainframe, you need to run something on the distributed side. So all the logic and the dependencies will be managed from the mainframe. So let's imagine this. We have a mainframe legacy scheduler in the middle, running the job 1, but after that, the job 2 must trigger a job on the distributed side, monitor its status, and collect the output and the logs. We can do it using the automation API. Then job 3 is a GCL that will be executed on the mainframe. And also job 4 is the same case as job 2. It's another GCL that will trigger another script or another job on Control M for distributed. So this is very useful when you want to avoid modifying the scheduling logic of the applications. So all the logic will be managed from your legacy scheduler. But you will take leverage of Control M capabilities using the automation API. All the requests that we are going to do against the automation API are synchronous. So we can monitor the status of the remote job. So this is one scenario. Let's describe a different one. Let's imagine we have a pre-scheduled workflow in Control M. So again, we have a legacy scheduler running on the mainframe plus a Control M for distributed. On the right, we have represented here a data pipeline workflow, which is a bit more complex than before. So we are extracting some information from different kind of databases. We are moving the files and the data to an S3 packet in AWS. And after that, we are using different kind of connectors. So the pre-scheduled workflow is waiting for an input event that is coming from the mainframe. So the job 1 will be executed, then job 2, then job 3, and job 4 is in charge of adding the input condition or input event that the data pipeline workflow is waiting for. We are doing this using the automation API. So it's very useful when the main flow starts on the mainframe and then ends on the distributed world. You don't need to track the status of the flow because you just need to add an event or a condition. And this is a very light process. We're just creating the event using the automation API, and that's all. Control M will take care of everything. Now let's discuss a little bit about the architecture. We have on the left a mainframe, and on the right we have Control M for distributed. So on the mainframe we will have a GCL that is in charge of call to a REXX program that has all the logic, and also that REXX program is using different files to configure the environment. So using these three elements, we are going to create an HTTPS connectivity with the automation API, meaning that all the information will be encrypted. Once we have created this connection from the mainframe to the automation API, we will be able to take leverage of all the services that are exposed through the automation API of Control M. So it's very easy to build your own integration. Now let's jump into the benefits. As I said before, the best scenario is to have Control M for mainframe plus Control M for distributed. But this is a different approach. So the benefits of using the automation API from the mainframe is that you can add the logic into the GCL. So you can put the step to call the automation API in the middle of your business logic of the GCL. You can order a remote process from the mainframe. You can also monitor the status of that remote process and also collect the logs and the outputs. So everything will be stored on the mainframe if you need it. You can add or remove events. It's very flexible to adapt to your requirements. Using the automation API of Control M, you will take leverage of more than 250 services available. You will be able to run synchronous or asynchronous requests. And you don't need to install Control M for mainframe if you don't want to do it. Again, as I said before, this would be the best scenario. Control M for mainframe plus Control M for distributed. So this is an example of how to add a condition. This is an example of how to order a remote job. This is how you will see the output, okay? The result in Control M in the monitoring domain, in the graphic mode. And also, this is the output coming from the enterprise manager to your mainframe. So let's talk a little bit about the resources. We have a GitHub repository with all the information you need to implement this solution, with a step-by-step configuration guide and several examples about how to do it. Also, we have here the automation API documentation. If you want to create your own integration, you will need to consult or check this web page. Also, we have here the prerequisites. You will need ZOS 2.2 or higher, access to the Unix system services. If the certificate stored is not managed in REXX, you will need access to the Unix to store the certificate in a specific key store. This is because the communication between mainframe and the enterprise manager will be encrypted. And as this connection will be encrypted, you need also ICSF running on your mainframe. Also, you need REXX, because our integration is built on REXX. Policy agent, if you want to manage the security out of the application layer, you need access to the policy agent. And finally, ZOS Client Web Enablement Toolkit. Now it's demo time. So let's jump into our mainframe environment. So welcome to our mainframe environment. As you can see, we have a GCL with some comments, instructions, and a brief description of each parameter. If we go down, we'll see the step in charge of triggering the job on the distributed side. In this example, we are using a catalog procedure in order to encapsulate the logic of the GCL. Let's take a look at the variables. In this example, we are going to trigger this job that belongs to this specific folder, and it will be executed in this control-M server. As you can see in the step, we have three files: credential, params, and in.json. Credential has the information about the user, password, certificates, token, and so on and so forth. And parameters has another information, like the endpoint, if we want to activate or deactivate debug, if we want to trigger asynchronous or an asynchronous request, and so on and so forth. Now let's put the focus on the in.json file. This configuration must be sent to the automation API in order to trigger the specific job. So as you can see here, we are using the same variables: server, folder, and job name. And also we are using a different kind of parameters. If you want to check all of those, you can check the documentation of the automation API. Finally, we have some variables. In this case, we have defined bar time and exit. Bar time has the value of 10 and exit the value of 0. So let's go to our control-M environment to explain this. So this is the job that we are going to trigger. As you can see, this is an operating system job. And we are doing just an echo. And after the echo, we are doing a sleep using bar time variable. Remember that this value will be 10, meaning that this job will be sleeping for 10 seconds. After that, we are going to do an exit using exit variable. Remember that the value of this variable will be 0. So at the end, this job will finish successfully. So let's go back to the mainframe and run this GCL. If we go back to the control-M and then to the monitoring and do a refresh, as you can see, we have triggered the job. And right now it's doing a sleep 10. Going back to the mainframe, let's take a look to the job and the spool. So the job is running. And as you can see, we are displaying some information, relevant information. Also the run ID. And every 10 seconds, we are monitoring the status of the job. Of course, this parameter can be modified. So you can check every 10 seconds, every 30 seconds, you can configure this parameter following your requirements. So this is the output that comes from the automation API. So at the end, as you can see here, we are collecting the output of the job and also the log of control M. Now let's replicate the other scenario. Going back to the control M, let's imagine that we have a predefined workflow that is pre-scheduled. Okay? In this example, I have this. As you can see, this smart folder is waiting for an input condition, input event. So I will order this workspace, and it will be waiting until my process generates this event. If we click on waiting info, we see that it's waiting for this event. So let's go back to the mainframe and let's add this event. For doing this, we have a similar GCL with some information, description, and of each parameter. And this is the step in charge of creating this event. Again, we are using a catalog procedure to encapsulate the logic of the GCL, and we are using also the same credential and parameter file. In the input, we are adding this sentence. Add the name of the event, the current date, and the control M server. So let's order this. It's finished. Let's go back to the control M. And as you can see, the flow is right now executing. Let's go back to the mainframe to check the output of the job. This is the job. And as you can see, we are providing some relevant information and also the answer from the automation API saying that we have created the event successfully. So that concludes our demo about how to order a remote job or create an event on for control M to start a pre-scheduled workflow. So thank you very much for watching my video. If you have any doubt, any suggestion, feel free to contact me and I'll try to help you. Thank you.